Let's turn our attention to the eye now, which, like the mouth, needs to be surrounded by concentric edge loops for the sake of deformation. So this workflow will start simple, but we'll get a bit more complex towards the second half. But starting off, let's turn off our subdivision surface modifier, tab into edit mode, and I will simply start by extruding edges that are, approximately the same length as what we have started with surrounding topology. Control right-clicking around the eye. That's actually probably a little bit too far. Surrounding the eye in about the same sized edge loops, or edge lengths rather. And then we need to connect down into this portion of the topology. Probably need one more edge at least. Okay, I think that's fairly even. Oh, but I don't even have snapping turned on. That's becoming a common problem for me as I've been recording this. So I'm going to reselect those verts and then snap them. And I need to decide if this is enough geometry or too little. Also, I want to have the same amount of verts on the upper half as the lower half, but that's just something to keep in mind. I want to finish extruding a complete edge loop or ring of faces. Right now it's just a loop. And so I'm going to start from here, and this is going to be a 5-point star. That's okay. We're going to extrude it straight up towards the eye, and then I'm going to extrude around, matching the verts that surround it. And you may notice that I'm kind of connecting the extremes like we've been doing. So this is the inferior palpebral fold on the bottom, and I'm continuing into the superior palpebral fold. And once we get to the caruncle, I think, yeah, this will work fine. We should be connected with the same amount of verts. Excellent. We've got a concentric edge loop or ring of faces to begin defining this a little bit better. So we do want the same amount of verts on the top and bottom. Now for the caruncle, we're going to think of these two verts, which will become the caruncle, as one vertex in the corner, matching this single vertex in the outer corner of the eye. So that means that the verts in between those points need to be the same. So we've got only 5 on the top, and then on the bottom, we've got 7. So I need 2 more on the top. So we'll just use Control R and cut 2 more edges up here, and then kind of space them out. I can focus more on the shape and then use our space tool, control clicking. Note that if you just control click from point to point, it'll connect the shortest path. So you can connect in the middle, control up here at the top, meaning you're defining the path you want it to take, and then control click one more time to get that exterior edge. And then right click loop tools and choose space, click, left click to snap that to the surface. We can do the same thing here, right click loop tools space, and then just massage those so that they do connect into the superior palpebral fold. And same thing on the bottom, we might as well make those spaced out evenly. There we go. All right, so now these are all, whoops, I didn't mean to move that. These are matching on top and on the bottom. Perfect. And then this corner vert matches the 2 on the other side, but I already went over why it's 2 versus 1. Now let's continue a new edge loop inward to the next extreme, which is the edge of the eyelids. All right, control right clicking all the way around. And then fill those faces. And they're pretty even, maybe just a little bit of tweaking. But you may notice we have a very uneven width of faces or height of faces, depending on how you look at it. So these faces at the top are very squashed, whereas these are kind of elongated vertically. And the reason is we really should think of neutral eye topology as eyes closed rather than open, meaning when these verts are scaled way down. Okay, so this sort of simulates an eye closed. And when that's the case, the faces are stretched significantly. So the action of opening the eye and closing the eye, we'll see the eyelids compress and extend. And so we need to keep that deformation in mind so that we have enough geometry to accomplish those shapes. And whenever the eye is opened, especially the top eyelid is going to have compressed geometry. And that is why, if I undo this, these faces are so small and compressed. And so for the eye, we really do need to think about the deformation and how the mechanics of the eyelid is going to work. But since we are modeling this with an eye open shape, the faces and edge loops will be very compressed on the top eyelid. So the next step, I think, is just Control R, cutting a new edge in the outer eye ring so far, and then G, left click to snap. All right, so this is going to give us more definition, which we especially need if I turn off the in front visibility. I especially need for the overhang of flesh here that is the superior orbital fat. And even with one new edge loop, that's simply not enough. We really need about 3 edges out of this single edge. And once I have that, it'll be enough geometry to accomplish the form of that mass of flesh. And so the way I will do this is selecting an edge that encompasses that shape. I think about here, and then Control B to bevel the shape. And I want to use % and crank that up. Also enable the segments to 2. And now I've turned the single edge into 3 edges. And why this is important to go from 1 to 3 is that we can once again use our diamond junction. Now, should I... Okay, yeah, I'm going to merge this way. And then down here, also merge. If I delete the central edge in those triangles, now we've got a diamond junction with additional geometry that will fulfill that superior fat overhang. And this part does get a little bit tricky. The first thing I need to do is that this edge doesn't actually snap to the surface of where the superior palpebral fold sits. It's actually much higher. If we can somehow see this, you can see in the sculpt geometry that where I have selected is the snapped verts to that crevice, but the crevice sits way higher. And so what I'm going to do is try and snap this. I'm just going to select the sculpt mesh and the retopology, go into local view, and then from the inside, I'm going to try snapping these verts. You can see just how big of a difference it is. So these verts need to snap up like this. It's a little bit confusing in here to kind of get used to this visualization. But this is going to be a big step into a believable mesh structure that accomplishes the anatomy along with the shape. Okay, so now that's a more accurate depth for that fold. And it also spreads out the geometry so we can start sliding this down closer to it to help with the definition. All right, so the snapping is hit or miss here. Sometimes we can snap. Actually, I wonder if we can snap. Okay, we can see as we circle around just how far this flesh overhangs. So let's try snapping at this point. Okay, I can snap that. I think that does make sense to snap. But I'm not going to snap these verts, at least not from this side of the face. Okay, so now we can bring these edges down, snap them. Basically, we can snap as long as we're on the exterior, but once we get inside, there we go. Now that geometry matches the shape of the sculpture much better. Also the anatomy, because it's just kind of weird to think about that fold is up in the eye, kind of folded in on itself. Whereas everything we've dealt with so far has been kind of cut and dry, snapping verts to the exterior. But now that we've got that geometry established, I actually want to push that fold a little bit higher. Okay, so we're going to turn snapping off because that doesn't really affect us here. And I'm also going to leave local view because I'm going to select our eyeball geometry, right, which has the origin at the very center of the sphere. I'm going to hit Shift S to snap our cursor there. And then with our cursor established, that becomes our axis by which we can rotate these edges upward around the eyeball sphere. Okay, so I'm going to find an angle about like this. Sometimes I use orthographic just to make sure that these verts are kind of aligned as I rotate them. But switch to our 3D cursor and then rotate these up. I'm just going to go a little bit, deselect the outermost verts, kind of do that feathered rotation. There we go. All right, so now this is even more accurate to what that fold would actually be anatomically. Okay, so it's kind of tucked way up under there. And I think we might be okay without messing with those other verts, but just to test, let's enable subdivision surface. Okay, so that fold is deeper, but it's also not as tight. It's not as crisp. And so I think what I will do, let's enable the subsurf modifier in edit mode. So that happened pretty quick, so let's go over it a little slower. What I did was I wanted to see the modified geometry in edit mode, which we can enable with this icon here, the triangle with 3 verts on each point. And now we can visually edit the smooth version of our mesh. Also, you might notice that the order of these buttons is reversed in Blender 2.93, just to confuse us. I'm going to slide those down a little bit, and also Alt-S to push them outward, feathering how much I push them, Alt-S. Okay, so at this point, we have a much tighter, much more anatomically viable structure to our mesh. And I am spending, time here because this is important. If your eye does not look like this, if you don't match the structure anatomically, your eye is always going to look a little bit off. And so I am quite happy with that. I think I will kind of take a breather from the intensity of that. I know that it can be a pretty intense, back and forth, snapping, not snapping, looking on the inside of the eye, and overall just an intense process. And so I'm going to kind of take a breather by extruding another face loop. And none of those snapped, of course, because I forgot to turn it back on. Okay, back to the eyelids. So we've established the superior palpebral fold. Now we need to fill out the geometry for the eyelids themselves. Remember we talked about how the eyes closed? You need to think of that as the default. And so if we do that thing again where I scale down using the active element and we approximate an eye closed shape. This geometry in here is nowhere near dense enough to accomplish a rounded shape. Remember, it's going to be conforming to a spherical eyeball, and this is flat. So we need more geometry to establish the round contour. And so I think probably 2 will be fine. Yeah, so I'm going to cut 2 new edge loops in this face ring to accomplish that structure. I'm going to undo where I scaled them down, and then Control R, cut 2 edge loops there. And then I will snap only what's not tucked underneath that fold. There we go. That looks good. And that should be enough geometry to accomplish eyes open, eyes closed. Remember, don't be off-put by how compressed this geometry is. It's all done for the sake of deformation in case we decided to animate this. Let's just spread out some of these edges so they're not so compressed themselves. And then the only thing we really have left to do concerning the eye is establishing the thickness of the eyelid and an interior socket, much like the mouth cavity. And so to accomplish this, we're going to mostly do it with snapping turned off. And I like to simply fill this opening for the eye and then inset a little bit with eye, just a little bit, and then Alt-S to push it backwards. And this is where I will establish the thickness of the eyelid. Maybe go back a little bit more, though you can't really do Alt-S twice. You kind of need to do Alt-S just once. So let's undo and make that a little bit thicker. And you can look on the other side to kind of get an idea from the sculpture how thick we want it. And then I will E to extrude one more time, a little bit in. This is a temporary extrusion to cut a new edge loop, and then Alt S. All right, so when you Alt S, you kind of need a perpendicular set of faces for it to extend out from. And that's why I extruded inward first. But now we've got the beginnings of the interior wall of our eyelid. Then all this temporary geometry can be deleted. So I'll select the face and then X and choose vertices. Okay, now we're left with just the interior wall. And I want to double check that the interior wall is maintaining thickness with the exterior, and it's actually getting a little bit thinner. So maybe I can move it as a whole, hitting G and then Shift Z, kind of move it backward, aligning it with the eyeball mesh a little bit. Okay, that's actually a little bit too far. Now the eyeball or the eyelid thickness is getting thicker the further we go inside. So I'll move it back just a little bit. Okay, and now we can see that that eyelid thickness makes a little bit more sense. Now, for an eyelid socket itself, the same concept as the mouth cavity, whenever we're working with subsurface shading, we really want a watertight mesh. We don't want to leave big holes in the mesh. Like right here, I could leave this, and technically it looks fine from the outside, but that could present problems for the subsurface shading because we don't have any big holes in our skin. It's all cohesive material, and I want to emulate that in our mesh. And the easiest way I like to do this is counting the number of verts in this exterior ring, which is 17. Bummer, I don't usually love when there is an odd number. While I'm thinking about it, you know, you could probably snap this interior eyelid to match our sculpture if you wanted. There we go. And yeah, so the odd number, it's okay. I mean, it's not a big deal. It's just sort of like modeler's OCD. It does bring up this fact as I'm trying to think, like, should I add another edge loop somewhere? I don't really want to do that because, you know, these edges are matching, and that was also a priority that I wanted to maintain. But there is a place that I can add a little bit extra geometry. And if I hide my retopology mesh, that is the exterior corner of the eye, because the upper eyelid does hang over the bottom eyelid like a shelf right here. And we sculpted that, but our geometry does not support that shape. So if we Alt H to reveal our mesh, what I can do here is do another diamond junction. All right, so if we cut a new edge like this, Control R, and then let's turn off our in front and snap this to the surface. All right, we can start to outline that kind of overhang shelf. And then we'll turn on in front again. All right, let's see what that looks like smoothed. And as simple as that, we kind of have that geometry better supported. And it adds more geometry if we go into local view, headed towards the inside of our eyelid. And this doesn't actually solve our odd number problem. We're going to have to do a triangle. I suppose I can do something like this, where the triangle is right here. The triangle is fine in here because it doesn't matter. You're never going to see this geometry, even if it doesn't deform perfectly. So that's not a big deal, but it does bring our vertex count to an even number. I don't know why I'm fretting about that. It really doesn't matter. What the problem with this is now we have a small edge surrounded by bigger edges. So that's another problem. I think I'm just going to leave it odd number. We'll leave this a diamond junction. And who cares that we have an odd number? It's not that important. We're on the inside of the eye socket. Not a big deal. And so a 17-sided sphere, that's what I want to add at this point. Let's leave local view. I'm going to select our eyeball. Actually, our cursor is already at the eyeball, which is perfect. That's what I want. Tab back into edit mode on our retopology mesh, and let's hit Shift A and add a sphere, UV sphere specifically. The segments, that top one, I'm going to make the number of verts we need, which was 17. And then the rings, basically divide that by half. Let's make it 9. 9 would have been half of 18, so it's pretty close. For an even sphere, you usually want half the number of rings versus the segments. All right, so with that created, we can scale down. Let's actually undo that and turn off snapping. Also turn off clipping for the mirror modifier. Okay, from the top, I can scale down and loosely match the size of our eyeball. Rotate in X 90 degrees. Okay, this will make our 17 segments face forward, which will tie into the interior eye socket vertex count. Okay, now I can go into local view, and I need to decide where to cut off the front of our sphere. I think right about here we can get rid of these verts and then delete this portion of the sphere. Okay, so we're going to have these 17 verts tie into these 17 verts. And I'm just going to, it's going to be a weird connection at first. Like this, the interior eye wall is not round like this is, but with a combination of vertex sliding, it'll be fine. So I know that they will match based on vert count. So let's just start filling. Let's see, it gets a little bit too slanted. So let's just fill and deal with the mess afterwards. We know it'll fill fine. Okay, now then select everything, shift in to make consistent normals. All right, and we're going to slide on both of these, okay? First, we're going to try and make it match the interior eye wall. Okay, so we've got this beginnings of an eye socket. It's actually a pretty big difference. I wonder if my sphere was too high. No, it wouldn't have been. That would have matched the eyeball. What I should have done then is done this. Rotate according to the 3D cursor. Yeah, rotate down like that. Okay. And then let's see, in here, let's just try and smooth this geometry out. Again, being on the inside of the eye, it's not terribly important. We just don't want it to have this odd like crevice and tight edge in there. What we could do is switch to sculpt mode. If I shade smooth and then add the wireframe overlay, let's jump into sculpt mode, and with the shift smooth brush, we can kind of smooth this stuff out. Okay, make it a little more consistent in terms of edge flow. There we go. That's going to be fine. And the only other thing that leaves is the caruncle, right? So from the outside, the caruncle has this sort of indent, but then it's filled with a membrane-like structure. So the way I like to accomplish that is jumping into edit mode. And similar to how we accomplish more geometry for the superior orbital fat, I will do that. Select these edges, Control B to bevel. All right, that provides more geometry, turning one edge into 3, which means I can create a diamond junction. Dissolve those edges rather than delete them. And now I can remove these faces with new geometry that represents that membrane. Fill it from the backside as well. Kind of slide these or jump into sculpt mode. Smooth those out. There we go. And then for the caruncle, I do usually like to inset and kind of push out this geometry. Okay, that's a much more simplified structure to the caruncle. We can turn off wireframe and enable our subdivision surface. And there we go. That is much better, much more eye-like structure in the geometry. We've got our anatomy accounted for. And then if we, let's see, turn off the in front visualization, Alt-H, actually leave local view, and then hide our sculpture, we can see that our eyeball geometry sits in there pretty nice. And we are set up very well for potential animation and proper deformation, as well as continued sculpting and get that high resolution detail in the eye. So yeah, I'm pretty happy with this. This is definitely one of the more difficult portions of the face. I think it's the hardest between the nose, mouth, and eye. But this is also kind of the last really important deforming area of the face. And so for the rest of the head retopology, we can relax a little bit in terms of deformation. So in my opinion, this is a milestone in the overall facial retopology.